All right, problem 6, we're going to find the design discharge for a roadway ditch along a primary roadway south of Asheville. And so it looks like we're going to have to find a composite coefficient, and we are told the time of concentration. So let's go ahead and figure out the storm, what design storm we're doing there for a roadway ditch along a primary roadway. So to my table 3.2, primary roadway, roadway ditch, we've got a 5-year design. So that's a new one for us. I don't think we've done one like that yet. So 5-year design. And we're told that the time of concentration is 12 minutes. So we could just go ahead and find that intensity first, since we've got that info, and then we can go back and solve for the coefficient. So we're going to have to go to that Asheville chart, which is the last chart here in your list, and time of concentration is 12 minutes. So we're really between this 10 and 15 here, a little bit to the left of halfway, but let's just go ahead up about the halfway there and see where we intersect. And yeah, we're a little shy of that 4, so maybe 3.9 or 4. I use both of those for that, but something in that neighborhood for that intensity. So let's do could be 3.9 inches per hour, could be 4 inches per hour. We'll solve for both of those. And let's go ahead and find that composite coefficient. So I've got that procedure pretty well down here. We've got all our different areas. So we have 0.95 acres. We have 1.15 acres. And we have 2.05 acres. And then we're going to have all these different coefficients that are given to us. So 0.9 for the first section, 0.35 for the second, and 0.5 for the last. And then we'll go ahead and multiply each of those individual areas by its individual coefficient. For the first one, we get 0.855, second one 0.4025, and the last one 1.025. And we'll add up our first column, so it's a total of 4.15 acres. And then add up our last column, we get 2.2825, and that's also acres times that coefficient. But when we go ahead and find that composite, remember we're just taking the weighted average, so it's going to be acres divided by acres, so we can drop those units off. 2.2825 divided by 4.15, and that does give us a composite coefficient of 0.55. 2 decimal places. Okay, so now all we have to do is put it into our calculator. Again, I'm going to use those 2 different I values, so let's use that rational equation. Q equals that composite coefficient times intensity times the area. So if I've got it for that first 3.9, I'm going to have Q equals 0.55 times 3.9 inches per hour times my 4.15 acres. And remember that that's going to equal to cubic feet per second. So with the 3.9, I get 8.9 cubic feet per second. And then I can also use the 4, so all the same info, just putting in 4 inches per hour. So it just does make a little bit of a difference what I you choose off of that chart. 4.15 acres. So that's just going to affect it just a little bit. It gets me up to 9.1 cubic feet per second. So pretty close, but really anywhere in that ballpark for this estimate for that design discharge would be fine.